Well, hello, and welcome back to Statistical Methods. This is Dr. James Wood, and today is class 4 in the course, and the topic today is the standard deviation. Now, before we get started, let's review some of the topics that we covered in the last lecture. First, we discussed the mean and the median. The mean is also called the average, and the median is the score at the 50th percentile. The mean and the median are both called measures of central tendency because they both give us an idea where the center or middle of a distribution is. Now, when we were talking about the median, we also talked about percentiles. And when we say that a score is at the 50th percentile, we mean that 50% of all individuals have scores that are equal to or lower than that score. Now, second, during the last lecture, we discussed how distributions can be symmetric, positively skewed, or negatively skewed. Now, in a symmetric distribution, the two sides of the histogram look like mirror images of each other. The mean and the median are equal to each other. In a positively skewed distribution, there's a long tail that points in the positive direction. That is, it points toward the right. And the mean is pulled toward the tail and is further right than the median. A negatively skewed distribution is the opposite of a positively skewed one. In a negatively skewed distribution, the tail points in the negative direction, that is, toward the left, and the mean is pulled toward the tail and is further left than the median. Now, finally, in the last lecture, we explained two closely related concepts: the distance from the mean and the deviation. The distance from the mean tells you how far someone's score is from the mean. Distances are always positive or zero. They're never negative. The deviation is very similar to the distance from the mean. It tells you how far someone's score is from the mean. And the deviation tells you whether that score is above or below the mean. A deviation is positive if the original score is above the mean, and a deviation is negative if the original score is below the mean. So deviations can be positive, negative, or zero. Okay, so today we're going to talk about several new topics. And the first topic we're going to talk about is variability or dispersion. These two words mean pretty much the same thing. Variability or dispersion is the amount that scores in a group differ from their mean. Now, let me explain this. This is a histogram that shows the rainfall per year in inches in a certain part of the world. The data is for about 120 years. The x-axis, that is on the bottom, shows the number of inches of rain per year. And the y-axis, that's over here on the left, shows the number of years that had that much rain. So this middle bar shows let's see, above the x-axis at what? 34 inches. You can see that. That's about 34 inches. And the height of this bar is about 10. So this bar shows there were about 10 years with 34 inches of rain. Now, ask you a few questions and to help you think about these questions. It'll help you to understand this graph. First of all, about how many years were there in the past 120 years that had 25 inches of rain? Okay, well, I'll show you here. 25 inches of rain is right about here. And if we go up here, we see the height of the bar is about 3. So there, in the past 120 years, there were about, 3 years that had 25 inches of rain. Now, here's another question for you. Is this histogram a frequency histogram or a density histogram? You come up with your answer, and then I'll tell you what the correct answer is. Okay, so this is a frequency histogram. And we know that because over here on the y-axis, it says that the y-axis measures the number of years per 1-inch unit. If it was a density histogram, the y-axis would show the percentage of years, right? That would make it a density histogram. The real difference between a density histogram and a frequency histogram is that the frequency histogram usually has a number over on the y-axis. The scale is for that, whereas a density histogram has percentage per 1-inch unit. Now, this green bar shows that the mean rainfall for all these years is 33 inches per year. I looked it up. That 33 inches per year is about what Dallas, Texas gets, and it's a lot more than El Paso gets per year. Okay, now here's another histogram, and this is for a different place, and it shows the same thing. It shows the number of inches per rain and per year, but it's a different place than the histogram we were just looking at, the one that was kind of like for Dallas. Now, as you can see on this histogram, the average amount of rainfall per year, that's right here in the middle, is about 33 inches per year, about like Dallas. So this histogram has exactly the same mean as the red histogram we were looking at a second ago. But you notice this histogram looks a lot different from the red histogram, even though the two histograms both have the same mean. Now, if we look at this, we can see that the maximum rainfall in this place was about 61 inches. There was 1 year over here on the right that they had 60 inches of rain, or 61. So that's a lot of rain. There's probably a lot of flooding that year. Now, if we look down here, we can see on the left, there's was another year when the minimum rainfall was 3 inches per year. So that must have been a terrible year with almost no rainfall. The crops probably dried up and died, and all the farmers went broke. Now let's take a look at the red histogram we looked a minute ago. Its mean is 33 inches, like we said, just the same as the other histogram. But this histogram doesn't show the same extreme weather that the other histogram did. In this place, the maximum rainfall was only 45 inches. There was 1 year where the maximum rainfall was 45 inches. So that's a lot of rain, but not nearly as much as the 61 inches we saw in the blue histogram. And in this histogram, in this place, we can see that the minimum annual rainfall was 21 inches. There was one year where it got 21 inches. Again, that's not nearly as bad as the 3-inch minimum we saw in the blue histogram. In fact, 21 inches is still more than twice as much rain as El Paso usually gets each year. El Paso gets about 8 inches per year. So even in this place, being shown by this red histogram, even in their worst year, when they had the least rain, uh, they still had a lot more than El Paso. Now, when we compare this red histogram with the blue histogram, we can see that the distributions they represent have the same center. That is, the mean is 33 inches per year for both distributions. However, the variability or the dispersion of the scores is much different in the two distributions. The scores in this distribution are generally closer to the mean than in the other distribution. So we say that the scores in this red distribution have less variability or less dispersion or less spread because the scores in general are closer to the mean. The histogram is narrower because the scores stay fairly close to the mean. If we look at the blue histogram, though, we say that in this distribution, the scores have more variability or more dispersion or more spread because there are a lot more scores that are far from the mean. The histogram is wider, it's more spread out because there are so many scores that are far from the mean. And this difference in variability between the blue histogram and the red histogram makes a big difference. If you were a farmer, which of the places would you want to live? The place with the blue histogram or the place with the red histogram? Okay, you decided? Okay, well, if you were a farmer, uh, you would probably prefer the place with a red histogram. Even though these two places have the same average rainfall per year, they're really a lot different. In this place, shown by the blue histogram, you'd have a lot of variability. So you'd have some years with floods and some years with total drought when there was almost no rain at all, only about 3 inches. In the other place, with the red histogram, the rainfall is more consistent, meaning you can count on the rainfall to be about right most years. You won't have those big highs and big lows. So it does, even though the two places have the same mean, the variability in rainfall makes a big difference. Now, an important topic in statistics is how to measure variability in a group of scores. We use the mean or the median to find the central or typical score in a group of scores. But we also need a way to measure how much the scores differ from their mean, how much they're spread out, how variable they are, how dispersed they are. So today we're going to discuss two ways to measure variability in a group. And the first measure of variability we're going to study is the average distance from the mean. And the second measure we're going to use is the standard deviation. Now, in the last lecture, we discussed how the mean and median are different from each other, but both of them have a similar purpose: to identify the typical, central, or middle value in a group of scores. In the same way, the average distance from the mean and the standard deviation are different from each other, but they both have a similar purpose. They both are trying to identify the variability in a group of scores. That is, how much the scores differ from their mean. So let's start with the average distance from the mean. And I'm going to show you how to calculate the average distance from the mean in a group of scores. This is the data we'll use. It's the ages of 6 children. And you can see the children's ages. They're 8, 9, 10, 10. There's 2 kids that are age 10, 11, and 12. So these are kids from about third grade to about seventh grade, right? Now, statisticians would call these the raw scores. The raw scores are what you start with before you start performing calculations. And what is N for this data? Now remember, N is the number of individual scores in the sample. So what is N for this sample? Okay, you probably got that right. There are 6 here, so N equals 6. Now next we need to calculate the mean. And I'm going to give you a second to do that. Go ahead. First of all, how do we do that? Right, the mean is what we call the average. So I just add together all the scores and then I divide by n. In this case, I would add together all the scores and then divide by 6. So go ahead, take a second to do that, and I'll wait for you, and then we'll continue. Okay. Uh, okay, I did the calculations too, and what I got was the mean of these scores is 10. So that means if you add these 6 scores together, you get 60, and then you divide by 6, and that gives you 10. That's the mean. Okay, now we're going to calculate the distance from the mean for each of the raw scores. So, if the raw score is 8, what is its distance from the mean? Okay, the distance of this score from the mean is 2, because 10 minus 8 is 2. We subtract the uh, we subtract the score from the mean, and that gives us 2. Now remember, distances are always positive unless they're 0, right? So they're always 0 or positive. If we get a negative number, we know we made a mistake. Okay? So what's the distance of 9 from the mean? Okay, got that? The distance is 1 because 10 minus 9 is 1. We just subtract the mean minus the score is 1. Okay, what is the distance for 10? What's the distance from the mean for this? Okay, probably got that. The distance from the mean is 0. Because if a score is equal to the mean, then the score's distance is 0. 10 minus 10 is 0. So you get the idea. And I'm going to fill in the rest of the distances. Okay, and you notice they're all positive numbers. The mean is always positive. For 11, we subtract 10 from 11, and we get 1. When we're doing with a distance from the mean, it's always going to come out positive, right? So we subtract the smaller one from the bigger one. Okay, now we're ready for the big moment that I've been telling you. Here's the question. What is the average, that is, what is the mean of all these distances? Now remember, we're not asking for the mean of the raw scores. We already found out that the mean of the raw scores is 10. But what we're trying to figure out is the average distance of these scores from the mean. And to find that out, we just add all these scores together, all these distances together, and divide by 6. So go ahead and calculate that. Add together all these distances, then divide by 6, since there are 6 scores, and get their average distance. Okay, and there's the answer. The average distance from the mean is 1. We got that because if we add 2 plus 1 plus 0 plus 0 plus 1 plus 2, we get 6. That's their sum. And then we divide by the number of scores, which is 6, and that gives us 1. So 6 divided by 6 is 1, and that's the average distance of these scores from the mean. So this number, the average distance from the mean, measures how much a group of scores differ from their mean. So it's a measure of their variability, their dispersion, or their spread. And as we've just seen, the average distance from the mean is equal to the average distance of the raw scores from their mean. In other words, we first calculate the distances for all the raw scores, and then we average those distances. Okay, so now we've discussed the average distance from the mean, and now we're going to discuss something similar to it, or has the same idea, but it's different, and that's the standard deviation. And this is the main topic of today's lecture, and one of the most important ideas in this whole course. The standard deviation is a measure of variability. So it's very much like the average distance from the mean. They're both measures of variability. So the standard deviation tells us how much a group of scores differ from their mean. Now, before I talk about the standard deviation, I want to alert you again that this is one of the most important things you're going to learn in this entire semester. We're going to be using the standard deviation again and again and again and again. It's just going to come back almost every lecture. We're going to be dealing with the standard deviation. It's going to become your close friend for the next few months, maybe for the rest of your life. So really focus on learning it, not just today, but after the lecture. Practice calculating the standard deviation and make sure you understand it, because this is one of the most important ideas in this class, and you need to understand this if you're going to understand the rest of the course. Now I'm going to show you how to calculate the standard deviation. We'll be using exactly the same raw scores that we use to calculate the average distance from the mean. These are the ages of 6 children, same 6 kids we had before, 8, 9, 10, 10, 11 to 12, kids ranging from 3rd grade through 7th grade. Now, before calculating the standard deviation, you have to start with the deviations. So before you ever get started, you need the deviations. Remember, it's called the standard deviation. So let's get those deviations first. Now, to get the deviations, we first need the mean. So, fortunately, we calculated the mean earlier when we were working on the average distance. So the average distance, the average or the mean of the raw scores for these 6 children is 10. Now, we're not talking about the average distance. We're talking about the average of their raw scores. So, we've got kids that are ranging from 8 years old in 3rd grade to 12 years old in 7th grade, and their average age is 10, which is about 5th grade. That's the average for the raw scores. Now we need to calculate the deviations. And first we'll calculate the deviation for 8. Now let's ask ourselves, will the deviation be positive or negative? Okay, you got that? Okay, here's the correct answer. The deviation for 8, we know it's, before we ever go a step further, we know that the deviation is going to be negative because 8, that's the raw score, is less than the mean 10. And if a score is less than the mean, then its deviation is always negative. So what is the deviation? Okay, the deviation is -2. So the raw score is 8, and the deviation of this score from the mean is -2. And there are two ways to get this answer. One way to get the answer is to use the official formula for the deviation. We covered that in the last lecture. The official formula says that the deviation is equal to the raw score minus the mean. So the raw score here is 8, the mean is 10, so 8 minus 10 is -2. So that's one way to get deviations. That's often the easiest way. We just subtract the mean from the raw score and we get -2. But there's a second way, a shortcut uh, that you can use a lot. You might want to try it. Just subtract the smaller number from the larger number to get the distance. In this case, you could subtract 8 from 10, which gives 2. Now, 2 is not the correct answer because 2 is positive, and we know the correct answer is negative. But we know that 8 is less than the mean, so it must have a negative deviation. So we just change 2 to -2, and we get the correct answer. So the shortcut I just was suggesting is that you can make things easy for yourself by, first of all, taking the score and the mean and subtracting whichever is smaller from the other. That'll give you a positive number. And then if the raw score is less than the mean, you just change the sign to -2. Now, why would you use this method? I use it all the time because I make fewer mistakes this way. It's easy for me to subtract the small number from the big number and then change the sign if it's wrong. Uh, uh, and I just find that I make fewer mistakes that way. But you use whatever of the two methods that works for you. But whichever you do, you want to practice this so it comes automatically. You don't want to be 3 weeks from now and say, 8, is that a deviation of 2 or -2? Do I subtract the mean from the score or the score from the mean? It's like you memorize one of these two methods and get so you just do it almost automatically in your sleep. Okay, so let's try it with 9. What is the deviation for a score of 9? Well, before we do that, ask yourself, is this deviation going to be positive or negative? Okay, give yourself points if you say it's got to be a negative deviation because 9 is less than the mean, which is 10. So since 9 is less than 10, its deviation is going to be negative. And what will it be? Well, depending how you do it, the way I do it is I subtract 9 from 10. That gives me 1. And then I know that 9 must have a negative deviation because it's less than the mean, so I change that to -1. Okay, let's try it with 10. What is the deviation for 10? Well, before we do that, we don't even have to do the subtraction, right? If a raw score is equal to the mean, we automatically know the deviation is 0. It's like if you subtract 10 from 10, no matter which one you subtract from the other, you're going to get 0. So the deviation is 0. So we can do this with all the numbers like this. Now, to check our work, let's calculate the mean of the deviations. What should this mean be? Right. The mean of the deviations is always 0. Doesn't matter which raw scores you start with. If you calculate their deviations and then you average those deviations, you're always going to end up with 0. So go ahead and check my work. See if you add these deviations together, if they come to 0. Okay. The mean is 0 because the mean of the deviations is always 0. That's a great way to check your work. If you say, did I do those deviations right? You just add them up and they should come to 0. If they don't, that's an indication you didn't do them right. Okay. Now remember, what we're really trying to do is get the standard deviation, but you have to start with to find the standard deviation, you have to start with the deviation. So we've got that. Now we're ready to actually calculate the standard deviation, and there are 3 steps. Once we've calculated, we have all the deviations lined up, then we're ready to go through 3 steps. The first step is to square each deviation. Okay, so let's see what that means. Here's our deviations, and let's square this first one. Let's fill in under the squared deviations. We have to square the deviation, which is -2. So what is the square of -2? Well, just a little refresher here. You haven't been doing squares lately. So to square -2, -2 squared equals -2 times -2. That's what a square is. You multiply the number times itself. -2 times -2 equals 4. Because remember, a negative number times a negative number equals a positive number. Okay? So here's how it works. -2 squared, that's how we write it with that little 2. There's -2 inside the parentheses, and then that little 2 written up there is what they call a superscript. That tells us we're going to square it. -2 squared equals -2 times -2, which is equal to 4. So we put the squared deviation 4 in the square on the right. Okay, now let's fill in this cell. We need to square -1. And what do we get when we square -1? Right, -1 times -1. You know it's going to be positive because a negative number times a negative number equals a positive number, and we get 1. How about this next one? Now that you see how it works, uh, what deviation are we going to square next? Right, we have to square 0. And the square of 0 is 0, because 0 times 0 is 0, right? Do this again. What about this? Square 0. Of course, we get a 0 again. We already did that. What about if we square 1? Right, we get 1, because 1 times 1 is 1. And finally, we're going to square 2, and what do we get? Right, because 4, because 2 times 2 is 4. So now we've squared all the deviations. And I want you to notice that all these squared deviations are positive, because when we square a number, we always get a positive number. If we multiply a negative times a negative number, we get a positive number. If the deviation is positive, a positive number times a positive number gives us a positive number. So squared deviations are always positive. And that's another way to check your work. If you end up with a negative number under squared deviations, that tells you there's a math mistake there. Okay, now we're ready for the second step of calculating the standard deviation. In this step, we're going to find the average of the squared deviations. Now, another way to say the same thing is that we're going to find the mean of the squared deviations. Now, here at the top of the slide, we do that. We do it the same way we always do when we find an average. We first add together all the squared deviations. 4 plus 1 plus 0 plus 0 plus 1 plus 4. And after we've added them together, we divide by 6. 6 is n, the number of squared deviations. Okay, now go ahead and calculate the mean of the squared deviations and tell me what you get. And remember, the mean of the squared deviations is the mean of 4 plus 1 plus 0 plus 0 plus 1 plus 4. Okay. Okay, so the mean of the square deviations is 1.666 because when we add those square deviations together, we get 4 plus 1 plus 0 plus 0 plus 1 plus 4. That gives us 10. And we divide by 6, so 10 divided by 6 is 1.666. And then it actually keeps going. 6. If you do it with a calculator, you get a bunch of sixes till you run out of spaces. Now, the mean of the square deviations is a very important number, and it even has its own name, and you need to memorize that name. It's called the mean square, or just MS for short, and you really want to memorize these names. Incidentally, I'm not going to keep, I don't want to keep bugging you about this, but today's lesson is really important, and you really do need to memorize these things, like what a standard deviation is, what a mean square is, and how to calculate it. Because what comes in the future depends on what you learn today. Now, we're looking for the standard deviation, and the standard deviation is the square root of this number. That is, the standard deviation is the square root of the mean square. So this brings us to the third and final step of calculating the standard deviation. We're going to calculate the square root of the mean square. And the number we get will be the standard deviation. So here's a box at the bottom of the table where we can write the standard deviation, which is abbreviated as SD. So what number should we write in the box? Go ahead and calculate that. Okay, here's the answer. The standard deviation is 1.291. And we got that number, 1.291 by taking the square root of 1.666. Because remember, the standard deviation is the square root of the mean square. Okay, so this is what we were looking for, the standard deviation. Now let's remind ourselves why we're even interested in the standard deviation. The standard deviation measures how much a group of scores differ from their own mean. And earlier today, we learned to calculate the average distance from the mean, which also measures the same thing. It measures how much a group of scores differ from their mean. Now, because the standard deviation and the average distance from the mean are meant to measure the same thing, it would be nice if they agree with each other. Wouldn't you agree? They're both supposed to measure how much a group of scores differ from their mean. So we'd expect the standard deviation, the average distance from the mean, to be the same or at least close. So let's check and see. We just calculated that the standard deviation for these scores is 1.291. And a little earlier, using the same 6 scores, we found that the average distance from the mean is 1. So here they both are. And you can see they're not exactly the same, but they're pretty close. 1 and 1.291 are close. They're a lot closer than if we got 20 and 1, right? They're usually. And this is usually the way it works out. If we calculate the standard deviation, and if we calculate the average distance for the same group, the average distance for the same group of raw scores, if we calculate them both, standard deviation and the average distance from the mean, we usually find that these two are pretty close to each other. But, yeah, so there we go. Sorry, they're close. They tend to be close. But the standard deviation is usually somewhat larger than the average distance from the mean. Now, so these two measures are both kind of measuring the same thing. They don't come out exactly the same, they come out close. But of these two measures, the one that we're going to be using again and again, the one that statisticians use all the time, is the standard deviation. As I said before, the standard deviation is one of the most important things you'll learn about in this class. And we're going to be using the standard deviation again and again and again in this class. So let's briefly review that part. I've shown you to calculate the standard deviation, you must begin with the deviations. So you have to calculate the deviations yourself before you get started. Then you perform 3 steps. And these 3 steps are, you square each deviation. Next, you average the squared deviations, and this gives you the mean square. Remember that. It's called the mean square. It's just the average of all these squared deviations. Then finally, you calculate the square root of the mean square. And this square root is the standard deviation. So let's cover some terminology that's relevant here. The standard deviation and the mean square have several names and abbreviations. So let's take a minute to review them. The name of the standard deviation is often shortened as SD. That's not too hard to remember. We'll be using this abbreviation a lot. So when you see SD in a statistics class, it means standard deviation. Sometimes I'll also say standard deviation. Sometimes I'll say SD. Either way, they mean exactly the same thing. Now, for the mean square, there are several names for the mean square. Sometimes the abbreviation is MS, like this. So in this course, sometimes I'll say mean square, other times I'll say MS, but either way, they mean the same thing. Now, the mean square is also called the variance. In fact, psychologists use the term variance a lot more than the term mean square. So, you really want to learn these names, right? And their abbreviations, standard deviation and SD, right? Or mean square, MS, or variance, and that they know that they all mean the same thing. Now, it's important to remember the relationship of the standard deviation to the mean square. And we've already covered this, but let's go over it again just to emphasize how important this is. As I showed you earlier, the standard deviation is simply the square root of the mean square, right? You get the average of the squares, and then you take the square root, and that gives you the standard deviation. Now, if the standard deviation is the square root of the mean square, then algebra tells us that the mean square must be equal to the standard deviation squared. As I said a minute ago, the mean square is also known as the variance. So in these equations, where we have written mean square, we can write variance instead. Now these two equations are really very useful. If we know the variance, we can always obtain the standard deviation. Right? Because the standard, we just take the square root of the variance, that gives us the standard deviation. Similarly, if we know the standard deviation, we can always find the variance because we just square the standard deviation, and that gives us the variance. So if we know if we know the SD, we can find the variance. If we know the variance, we can find the SD, and it's very easy to do. So let's check this out. Here's the first question, and I want you to take a second and try and figure it out for yourself. What is the standard deviation if the variance is 9? Okay, you probably got that right, but let's cover it. We can use this equation, which I showed you a minute ago. It says that the standard deviation equals the square root of the variance. In this example, we're told that the variance is 9. So we substitute 9 for the variance, and the SD is equal to the square root of 9. The square root of 9 is 3. So the standard deviation equals 3. And this is the solution. So in this case, we started out with the variance, and we easily calculated the standard deviation by simply taking the square root of the variance. Now here's another example. What is the variance if the standard deviation is 12? Now, remember, one of the formulas I showed you a minute ago says the variance is equal to the standard deviation squared. So in this example, we said that the standard deviation is 12. So we substitute 12 for the standard deviation, and 12 squared is 144. So the variance is equal to 144. Now, you want to learn these two formulas and use them so you can easily turn the standard deviation into the variance, and the variance into the standard deviation. Okay. Now, in the next class, that is in class 4, we're going to talk more about the standard deviation and about why it's important and why it's useful. And as I said, We're going to be using the standard deviation in practically every lesson in this course. So you really want to do the homework, read that chapter, and do the homework. It's not enough to say, oh, I remember what Dr. Wood said. It'll stick in my mind. No, it won't stick in your mind unless you practice by actually reading the chapter and doing those homework problems. Doing the homework problems, once you finish doing those homework problems, you'll have it. But that's the way to do it. Do the homework. Remember, that's probably one of the most important pieces of advice I can give you for getting through this class, and not just getting through, you can get an A. But you got to do the homework. But for right now, let's do a class exercise to give you some practice calculating the standard deviation. Now, normally, uh, before we have people, if we're meeting in person, um, we all have everybody get into small groups and work together to do this class activity. But if this is online, we're going to have to approach this in a somewhat different way. So let me show you what you can do for this. Okay, if you go, bear with me a second here as I switch this. Okay, here's a handout. If we were in a class, I would hand out, give you this handout and have you work in groups of 3 or 4 to work on the standard deviation. Now, if this is online, the way to do this is go to Blackboard and you'll find a folder there with handouts for the class. And one of the handouts is this one. It'll say handout for class 4, and it's calculating the standard deviation. So what you should do at this point is probably pause on this video and go and download this handout, and then um, once you've done it, come back here and start the video again, and we'll work through this together. So I'm going to wait about 15 seconds, but you can just freeze me. Okay, so now I'm assuming that you have downloaded the handout and you're ready to get started. So let's work through this exercise together. So here's a question. You notice on there, what do you begin with to calculate the standard deviation? Okay, well, you're going to need, remember, to begin with, for getting the standard deviation, you have to begin with the deviations. So, and to get the deviations, you have to first get the mean. So I'm going to give you, again, freeze me for a second, but go ahead and calculate the mean and then calculate the deviations and then come back and start this up again. Okay? Okay, now I'm going to assume that you calculated the deviations. I'm just going to review how you do that. The first thing you do is you calculate the mean of the raw scores. And the mean of the raw scores is 168 divided by 8, which is 21. So the mean is 21. Next, you calculate the deviations. right? So you do that by, remember I told you there are a couple of ways to do that. One way is just subtract the mean from each of these raw scores, and you get this. I told you another way to do it is to look at the score and calculate the distance between the mean and the raw score. So 28, well, let's look, I'll just give you a couple of examples. Okay, 28 is, the distance from the mean is 7, right? Because 28 minus 21 is 7. And 28 we know is above the mean, so it's the deviation must be positive. So 7, the deviation is 7. We got another example here of a raw score is 21. Well, what's the distance from the mean? 0. And that just tells us the answer right there. Now here's another one. We'll just do one more. 16. Okay, 16, the distance from the mean is 5, right? Because 21 minus 16 is 5, but that's the distance. The deviation must be negative, right? Because 16 is less than 21, so the deviation is negative 5. I won't go through all these, but I'm just, again, reminding you how you calculate the, the, the deviations. Okay, now, uh, and then also I want to call your attention here is that I added all these together and got their average. But the main thing is if you add together all the deviations, they always come to 0, and that's a way of checking our work. Okay, now that we have the deviations, what are our 3 steps? Well, what's the first step? Once we have the deviations and if we want to calculate the standard deviation, what's the first thing we do? Okay, we square those deviations. So take a second to do that, and then come back here. You can pause this video and then come back after you've done that, and I'll show you the correct answer. But do it for yourself first. Don't just kind of watch Dr. Wood do it. You got to do it for yourself, just like you need to do the homework, because that's what gets those neurons firing and really teaches them, and you can do well. There we go. Okay, so here's our deviations. I'm going to go ahead. I'm going to assume you've already done it yourself. What are the square deviations? Well, we can see that 7 squared is going to be 49. 0 squared is going to be 0. Some of these we might need a calculator. What's negative 1.5 times negative 1.5? I think that's 2.25, but let's see. Yeah, there we go. And we can see here's one. The deviation is negative 5. The square is 25. If the deviation is negative 1, the square deviation is 1, and so on. Okay. So we've just completed the first step of calculating the standard deviation. Now we're ready for the second step. What is the second step? Once I've squared all those deviations, what's my next step? Got it? Okay. The next step is to average those squares. So we average the square deviations. When we do that, that average has a name. It's called the mean square, or the MS. So we just take all the numbers in that column over there, and we say, what's their average? What's the average of 49, 2.25, and so on? Go ahead and calculate that. Pause on me, and pause this video, and then come back after you've done that. Okay, I assume that you have done that you have calculated the average of the squared deviations, and the answer is 13.06. We call that the mean square, or we call it the MS, or we call it, what's the other name for that? That's the variance. And remember, you got to know that name, so learn that. Okay, so now we're ready for the third step. What's the third step in calculating the standard deviation? Okay, third step is to calculate the square root of the mean square, and that's going to give us the standard deviation. So go ahead and do that. What's the square root of 13.06? Go ahead and get that. Okay, so remember the standard, I'm assuming you've done the calculation. The standard deviation is equal to the square root of the mean square. It's equal to that is, it's equal to the square root of 13.06. You don't know that, I'm sure you don't know that in your head, but your calculator will help you. The square root of 13.06 is 3.61. So there's the standard deviation. That's it. That's the square root. Okay, so we're done for today. I just want to review for you. We looked at two different measures to measure the dispersion or spread of a distribution, which is another way of saying how much the scores in a group differ from their own mean on average. And we used the average distance from the mean, and we also used the standard deviation. And we said the standard deviation is used a lot more in statistics, and it's probably the most important new concept you will run across in this course. So what do you want to do? You want to do the homework, right? Practice that. And practice is what the only way it's going to get burned into your neurons. And then so go through that chapter, practice calculating the standard deviation. If it seemed a little confusing today, you'll find out it gets much more clear if you read, do the homework, do the readings, do the homework problems. And next time we'll continue on this topic. And remember, um, there will be a quiz next time. So be sure and do that homework so you will be prepared. It's been a pleasure talking with you here today and introducing you to the standard deviation, one of the most important ideas in statistics. And look forward to seeing you at the next class.